me close this. So what I did is actually I can use this fuzzy. Okay, and after that you will see this window. Okay, so when you see this window, actually you basically goes from 1, 2, 3 actually there. So first is the input. Okay, so for the input, you can click on it. So you have 3 fuzzy sets already. You can add more there. Okay, you can add more sets there. Okay, but now we already have 3 there. So what you can do is the range actually is from what? Negative 75 to 75, and also, okay. So it's where change your workspace. Okay, to negative 75 to 75. Okay. So the first membership function, remember, let's choose this guy. This guy should be what? Positive, right? We want to have a positive. Okay. Oh, okay. Let's do the second one. Okay. Negative. So you can use MF too, no problem. But we already have a definition N. I can use N. Okay. And you will like it. You can just I don't have. Okay. Let me. I don't have mouse here. So let's do the 20 and 20. And you click on it. Okay. So you can also use the either the touchpad or any mouse to move it. Okay, but it's more accurate using this way. Change the numbers. Okay, change the numbers. So this is the N. Okay, and the membership function 1 should be what? This is negative or positive. It's a negative, right? So is that a trapezoid? Oh, it's a triangular? No, it's actually a trapezoid. Okay, so then I can easily change this. Remember, if you still remember what we did last time, negative 75, negative 75, negative what? Huh?
Negative
20. 20, yes, you remember this? Okay, so this is the
20.
Exactly 0. Okay, so then what?
That's not negative 75. You put positive 75 for one of them.
Okay, thank you. Yeah, here. So it's actually become, all right. Okay, thank you. Yeah, this is the N. Actually, exactly what we did last time. Okay, and it's also more intuitive right here. And of course, this guy is the positive. I just choose this as the positive, and I can choose this. You can see there's a lot of different membership function there. So it's 0, 20, 75, 75. Now, okay, so this is done. Okay, so this is the for the input. Okay, for the input. Okay, and this guy will be the output. Output is similar, but the workspace now is negative 7.5 and 7.5. Okay, and so this guy is also you can say this is the 0, but this is more like the 0 of the E, right? Let's use ZE, okay, or ZU. Okay, so this is the this guy should be, remember, from U2. Before it's 20, so now it's 1/10. Exactly. Okay, and this guy is say negative U. Okay, so this is trapezoid. Okay, so this guy is from okay, 0.74, 0.5, negative 0.75, negative 2, 0. right? The same thing. Okay, so this guy is the positive u. So here, this guy is from 0, 20, no, not 20 anymore. 7.5, 7.5. Okay. Okay, so you define all the membership function. Okay, and but now is the rules. Okay. So input. Okay. Anyway, so input is what? Input is, if input is n, what will be the output? NU, right? So then yes, one rule there. Okay. And when this guy is just I made a mistake here, right? Did I? Yeah, I named them the same here. This guy is a Z. Don't worry. Yeah, 0. Okay. And negative 0 and P. All right. Otherwise, there's a problem here. Okay. All right. So then you go to the rules here. Okay. Let me delete this. Okay. I don't know if this guy is the right one. Okay. But anyway, now n to nu, you add it. And when this guy is the Z, you go to Z, you add it. If this guy is a P, you go to P, you add it. And yeah, okay. So now you all right. So if now you can see the rules here. This is actually something interesting. Okay. So if the input is at 0, it will cut the DOF of what? The Z. So the DOF at that time is what? For the first one is 0. For the second rule is 1, and for the P is also 0. And so then you cut the output. So when you cut the Z, you actually have the whole thing there because the DOF is 1. So minimum of that is out there. So you add it together. This the last one here is actually the B prime over the. You have the B1 prime, B2 prime, B3 prime, and the last one is the combination. Okay. So if I can move it. Okay. This is actually something testing. It's not really necessary. So if you do this. It tells you actually if this is working correctly or not. So, the DOF there is kind of like 0.5, so you cut the P, the negative. Then also this is 0.5, you cut the 0. And then you B1, B2 prime, B3 is 0, of course. So B1, B2 prime together, you got this new B. And the late line actually is what? This is the center of the area. Automatically it calculated for. Okay. Okay. It's not the MOM, right? It's not the maximum, or the median of the maximum. Median maximum should be a little bit, this place maybe. So now if you like, you can actually. Then you have this, or if you like, you can test it like this. Okay, so this is the testing. Okay, so then after that you can you can export it to workspace. Okay, you can choose a name, say fuzzy controller 1. Okay, so this now is in the workspace, and also you need to export to the file to the disk. Okay, so there's no FC1. I put the FC1 here. Okay, so I put the FC1. So now you have the file. Okay, and the next time, for example, I already have something else here, so I can import from file. So I can. This is something I designed before, so I use this guy. This is something I designed before. Okay, and here I even have see this. You have the current value. I can before I said input 1, but here I make the more specific. It's E. You can do that also. Okay, and also the if you go here, this is actually you can change it to DU, and also this the range. Okay, what we got here. Okay, so. So the rules is also there, okay, and also the defuzzification is, see, it's already chosen, okay. You can use the MOM, okay. There's other ways, but we usually use the COA, okay. All right. So this is the controller.
So you just touch fuzzy in Matlab and then
Yeah, it will pop it up. Okay, to pop up. So it's very straightforward. You just define the fuzzy sets both sides. Then you do what? You put the rules there. It's actually automatically just and you choose the input membership function, output membership function. Okay. All right. So after we do this. Okay, where's my cruise control system? Here. Okay, I have have you noticed what I designed here, FC1, and also the one I just brought it out, the membership function of the output. Have you see the difference? Let me just let you see. Okay, it's actually okay. It's let me see here. Okay, this is the FC1. Okay, so if you click on this, this is from what? Negative 0.5 to 0.5. Okay, so that's the controller. Okay, and but I also let's just import. Okay, if you like, you can also name this guy as the DU. I don't have a problem with this. You can also say this is actually the E arrow. Okay. And I can say import to workspace, and I can also import this to the disk, this one. Okay. All right, and let me just show you. Actually, this is not a big deal, but be careful if there's any problem. This guy is the RTB, and this is just I designed. Actually, almost identical, only this guy. What the membership function here? The working range is what? Negative 75 to 75, right? Okay, so if we do that, you need to do what? When you get to the controller, you need to divide the controller by what? 10. Yeah. So that's why actually I want to show you. Okay, I don't need to save this. It's actually not a big deal, but we have to be careful, especially. Okay, let's close this. Here, see? I have this because you have this fuzzy controller. This block, just like the ILS we used, this block actually is in the Matlab toolbox. Okay, so you open the simulink. Actually, you can have this in the fuzzy logic toolbox. You can move that fuzzy controller, this guy. Okay, when you click on it, just like the ILS. Okay, here is the controller function I used. So this is the car TV because that is the output is 75 and it's negative 75. So I have gain there. It's 0.1. Okay. All the other things are actually, this is the system, the black box I gave to you, and this is the give you the arrow. Okay, arrow minus the current speed. Okay, 60 minus speed is the error. So I input this error into the fuzzy logic controller. This fuzzy logic controller should give me a DU. The DU I here, since I working on the same universe, I get a 0.1. And this guy will, this part is what? Just add to the controller. So this is the UK plus 1. And after a delay, this becomes UK. So UK plus the change will become the next controller put into the system. So this is actually the UK plus 1 equal to UK plus DU, right? So this is the structure. So now let's run it. Okay? And if you go to the, okay, what's going on here? It did not run.
There was an error that came up.
Okay, let me see. Yeah, I see it in red.
You just have it saved in the same folder?
Not same folder. It's probably not in the workspace. Okay. Let me just export from here, and I export to the workspace. Okay. Now it should be working. Again? Okay. So starting from 0, its speed will pick up to 65. Okay, 65, and you can run longer time if you like, and this can be 30, and also I can change this guy to say this is a constant. I can say my speed should be 70, and you run this, and you go to the scope here. So this is the 70. So the fuzzy controller you designed actually can work pretty well here, okay? And I don't know what is the inside that structure. I did not actually, when I designed the controller, I never click on that car model, right? Because I know how to drive a car, so I use the experience, put on the paper, say P to P, negative to negative, and 0 to 0, and it actually works. It works. Okay. So this is actually how we using the fuzzy toolbox to design a controller. It's the most important thing is to get the fuzzy set defined. Okay, then you add the rule there and save it to the workspace and also the disk. Okay. And you probably say, okay, this is good, but how we use this in the command window when you're trying to program a robot in embedded system, or what we can do. We still can do this. Okay, so let me show you what we can do. I will try, okay, I will upload the alright. So this one, okay, looks familiar, but before, remember, we have very long fuzzy sets there, okay, fuzzy rules there, okay. Remember, it's around this area. We have 6 or 7 lines to get the fuzzy controller. So now it's actually pretty simple. So you first do what? You first need to read the fuzzy controller we saved on the disk. So this is the second line. We're trying to read the FIS, fuzzy inference structure there. So do you read it? It's already saved. So then it will be in the workspace. Just like we had the error message before, right? We did not save in the workspace, so we had a problem using the fuzzy toolbox. So this part is the second line is just put that in the workspace. And third line to 5 line actually are all the initial conditions we did before. And then we do the for loop, and we first calculate the error. Okay, error is 70 minus VI. Okay, and then you calculate the controller. So how you calculate controller? The car FS is already what? It's already in workspace. Okay. So then you use the evaluate fuzzy system. You will get the value out. Okay. So this is actually a very quick way to calculate the output. Okay. Then you the 9 and 9 actually is the same as we did it before. You add it to the previous controller to get to the current controller, because DU is the change of the controller. And then you put into the system, that's the car system, and you press the bit. Okay? And then let's run this. Okay. So if you say 70, you got a 70. Okay? Actually, this is pretty nice. Okay, and it's better than the result we get from fuzzy logic controller last time, right? Because the controller I gave to you is very aggressive last time, but here this is based on our own controller. Okay, of course you will say this is still have a pretty big overshoot. Okay, how we solve this? But now we don't have Inago here. Okay. When you drive in a vehicle, do you have only 3 rules? No, you have more rules. Okay? If it's already almost the 70, I need to be careful, right? So when you drive in a vehicle, you have more than 3 rules. Okay, you will have to say, okay, this is very negative, then I press the pedal harder. Okay, but if it's kind of not very negative, I will actually, reduce the input. Okay, so in that case, you can have fuzzy sets, say, small negative, small positive, like that. So it will give you the better result. Okay, because only 3 rules will work, but not the idea for, when we drive in a vehicle, we, have more rules there. Okay, so that's the, if you have more rules, that's actually your homework problem. Okay. So I will ask you to design 5 rules. So instead of using negative, positive, and 0, I want you to add something between negative and 0, and 0 and between the 0 and the positive, something tuning. Yeah.
Is this slope linear due to the car's capabilities of how it can gain speed, or is that?
Yeah, because actually they still have a structure there. Car structure there. So if I change the parameter there, maybe it can go faster. Go faster. But you can also actually include those things in your rules, because if you are driving an 18-wheeler, driving a vehicle, you have different rules, right? But here, I actually did not consider those. I just consider I driving a regular for setting the vehicle. Okay. So yeah, as I mentioned here, if you want to change this to 60, this supposedly will give us. So this is the 60. Okay, this is the 60, and you have a little bit of overshoot there. But still, we only have maybe several seconds of overshoot. It's actually not a big deal. Not a big deal, right? So that's the fuzzy controller design, and this weekend I will upload all